I can't stress this enough. Do not try this at home.
Can I have your phone? I don't have mine, so if I need to call 911.
It was nothing. Well, I can't get the tool changer to work, so it should do a tool change. So it wants me to put tool 1 in the spindle, but if I push the unclamp button, it's gonna freak out. And it says spindle clamp and unclamp inputs detected. So there must be, I don't know, an adjustment required on a proximity switch or a pressure switch. Not sure. Alright, well, I think we're gonna have to stop here. We gotta get the machine down off of these skates and onto these blocks. So we're actually gonna have to go up with it. I'm using this little pancake jack. It's very handy. And I've got a bunch of steel shims that I can put on top of it. So it only has about, I don't know how much, very little stroke. That was the door rolling shut. I need to run the screw down a little bit because it's a lot easier to level it by backing the screw off than turning the screw down. Trust me. Okay. I moved the machine with these skates. These things are awesome. They're also kind of dangerous. The problem is they typically come as a set of 4, and you absolutely do not want to use 4 unless you want the thing you're moving to fall over. You want to use 3. That way it self-equalizes. I made this handle so I can turn one of them to steer, and it's got a bearing turntable on the top, and underneath they have almost like tracks, rollers. These things are rated for, I think, 12 tons a piece or something crazy, so it's pretty much impossible to overload them. The biggest problem I have with these things is unless the load is exactly in the center, they absolutely will not roll straight. If the load's just a little bit off to the side, they always want to turn in the direction of the load. And if you have a pair of them that you're trying to move in the same direction, pretty soon they're towed out or they're towed in. And if you keep pushing, they want to lean like this. And then the edges of the rollers will actually dig into the concrete, and this thing will roll over like this, and you'll push the machine right off the skates. And it's possible to knock the machine over doing that. So what I always do, looks kind of crude, but it works fantastically. I take a bar, it's just a piece of 3/4 inch cold rolled bar, and I clamp it to the 2 skates that don't steer. And that just keeps them moving in the same direction, no matter what. Now someday I'm just going to weld a tube onto each skate so I can slide a bar through them instead of having to use these little clamps. And then I put a block of wood on top of them just to keep the machine from sliding around. And then the other thing I like to do if I'm trying to move the machine by myself, I find a block of wood that's roughly the same height as the skates. That way, if it ever falls off the skates, it just falls onto the block of wood. I just drag that along with me while I'm moving the machine, kind of as a safety backup. It's pretty dangerous doing it by yourself. The best thing to do is have at least one spotter who can watch the skates, because like I said, you don't want it to fall off the skates. That's a bad day. I hooked up power. That was pretty straightforward. Now we need air, and that's where things get a little more complicated. This is not going to work. If you can believe the YouTube analytics, about 40% of the people watching this video are somewhere outside of the US, which means, at least on paper, they use the metric system. And boy, are they proud of it. Now, I'll be the first to admit that the US customary imperial system is an absolute dumpster fire. There's no question about that. But just because something is metric doesn't necessarily mean it's better. Let me show you what I'm talking about. This machine is made in Taiwan. It's 100% metric. All of the tapered pipe threads are BSP, British Standard Pipe. In the United States, we use NPT. So this is a 3/8 BSP fitting. This is a 3/8 NPT fitting. You can find this in any hardware store in the US. This guy has to be special ordered from a catalog. To the naked eye, they look identical. And indeed, they are extremely similar, because this is not really a metric fitting. It is based on the Whitworth system, which was based on the inch. It goes back 200 years. The only difference between these two fittings is a slight difference in the shape of the thread and 1 thread per inch difference in the pitch. Most people have absolutely no idea that there are more than one kind of tapered pipe threads, and they will happily thread these two fittings together, and in a lot of cases, it will actually work. The problem usually comes when you try to do it with hydraulics, where there's high pressure, and they just won't seal up no matter how much tape you put on them. Yeah, the great thing about standards is that there's so many to choose from. It's not just tapered pipe threads. This is a standard M10 bolt that you would find in Germany or North America. This is a standard M10 bolt that you would find in Japan. This is a DIN standard. This is a JIS standard. The hex size is different. The thread pitch is different. These are both standard threads. This is a JIS hydraulic fitting, Japanese industrial standard. You'll find this on any Asian-made machine. This is a JIC hydraulic fitting. I believe that stands for Joint International Committee. This is the standard in North America. They're two different sizes, but if I had the right size, they would actually thread together. The threads are pretty similar. Really, the only difference between the two fittings is the angle of this tapered sealing surface. And again, most people are blissfully unaware that there's more than one standard, and they will happily thread them together, and sometimes it works, and a lot of times it doesn't. I've seen a lot of Japanese machine tools with weeping hydraulic hoses, because most people just don't even know there's a difference. You know, you can find this JIC fitting in any hydraulic shop in North America. The JIS fitting, you would have to order from a specialty hydraulic supplier. Probably also costs about 3 times as much. While I'm on my soapbox, here's something else I don't like about the metric system. In the US, we use pounds, which is a measurement of weight. In the metric system, they use kilograms, which is a measurement of mass. Weight is dependent upon the force of gravity. Mass is independent of the force of gravity. Your mass on planet Earth is the same as your mass floating around out in space. Now, that independence from gravity is very handy if you're an astronaut or a physicist or an engineer. But for most normal people, who, by the way, all live on planet Earth, where gravity is more or less a constant, mass is not a very useful unit. In fact, it's kind of a pain in the butt. And I'll give you an example. This is a torque wrench. Let's just assume that it's 1 foot from the center of the socket to the center of the handle. If I weigh 200 pounds and I put all of my weight on the end of the handle, that's 200 foot-pounds of torque that I've just created. Now try that in metric. So let's say 300 millimeters from the socket to the center of the handle. I know that I weigh 100 kilograms. So how much torque is that? Well, we have to take 100 kilograms times the acceleration of gravity, 9.81 meters per second squared, times 0.3 meters to get Newton meters. With the pound, that calculation times gravity is already built into the unit that we're already familiar with. So it's just a lot more intuitive, at least in my opinion. Now, luckily, since the acceleration of gravity is 9.81, that's close enough to 10 that most people can do the calculation in their head and get close enough for everyday use. But metric is better, but maybe not always 100% better. This is the pressure regulator. So we'll thread in this BSP push connect fitting, which was missing when I got the machine. Don't know what happened to it. I'll have to go back and look. Maybe it was in the machine when I got it and I just tossed it. I don't remember. Okay, now that connects like that. And we'll connect up some 12 millimeter nylon airline. I'm going to use this 1/4 inch NPT to BSP adapter. There we go. That'll work just fine. I put this valve in because these machine tools pretty much always leak air. I got the machine kind of roughly leveled. Let's see if we can figure out the tool changer. I couldn't get it to work at all, but a kindly viewer sent me a copy of the manual for a VM2, which is a very similar machine. I believe it has the same tool changer. And I think we're out of oil. If I read the manual right, that cup is supposed to be 1/3 full. I can't really see any easy way to fill it other than going right in the top of the cup. So that's what we're going to try to do. Book says to use mobile DTE Lite, which I don't have, but I do have some DTE 24. Should be pretty much the same thing. So let's try that. It's easy enough. Well, that didn't hold very much. There's got to be something I'm missing here. So it should be like a whole reservoir in there. It works. Cool. That's all it's got to do. Fantastic. I'll take it. Okay, we're going to go ahead and do the kind of the precision leveling. So we're bang on at the back. So at the front we're off 1 tick. So we need to raise this corner of the machine just a tiny little bit. We're trying to get rid of the twist. That'll work. Now we do the same thing in the Y direction, but it's not going to be as easy to correct, but at the same time there shouldn't be as much of an error just because of the way the machine's built. It's much longer than it is wide. I'm just checking the tram. It'd be a whole lot easier if I had a light that worked. I took it apart and checked the bulb. The bulb is good, but I had no power. Spent about an hour looking through electrical schematics. Could not find anything about the work light. And I finally found out how you turn it on. You have to go to manual function setup, and then hit toggle work light. I think the tram's close enough for right now. It's within about 3/10. So if I'm being honest, the table's probably not flat within 3/10. The whole leveling concept is kind of confusing. So to help us understand, I made this highly accurate scale model. The Hurco is what's called a C-frame machine because the frame kind of resembles the letter C. It's a very common configuration for vertical milling machines. And we're not really trying to level it. What we're trying to do is untwist it and align it. It's kind of hard to believe, but even though this machine is made from 3 tons of solid cast iron, it can bend. Just a tiny little bit, but enough to make problems for us. So what we do is put a level on the table. We measure the level at one end of the travel, move it to the other end of the travel, and compare the two readings. That will tell us if there's a twist in the base of the machine. And we can correct that using the 4 screws on the outside corners. We need to go up just a skosh. And up in the opposite corner. When we're happy with the base, we can move on to aligning the spindle, which is actually the alignment of the vertical column. So we can attach a dial indicator to the spindle and touch it to the table. And you see it contacts at the front and the back, but it does not contact at the side, which means the spindle needs to lean a little bit in this direction, which we can do with these screws here in the middle. Now, it's probably not going to work very well because this model is pretty poorly constructed. But by using one screw, we can actually lean the column left or right. By using both screws together, we can lean the column forward and backward. And again, we're talking about tiny amounts, hundredths of a millimeter. Unfortunately, our cardboard milling machine was poorly made, and we don't have enough adjustment to tram the spindle. I think somebody installed it a little cockeyed. Anyway, that's the basic process, and it's iterative. You check the front and back, get that where you want it, and then you have to recheck the left and right, get both of them where you want it, then you set the spindle, then you got to go back and recheck the forward and backward, left and right, because every adjustment that you make affects every measurement. And a lot of times you can't get them perfect, you just have to get them as close as you can. If the machine's really, really worn out, there's nothing you can do about that. You're just trying to get the machine returned to the nominal position that it was made to. Got a little snag with the vices. I can't mount them with the normal slots because, that's not good. And based on the current amount of mangling, I would say I'm not the first person to have that problem. So we're going to have to move them forward a little bit, like so. And I ordered some new clamps to make that possible, but they haven't come in yet, so we're on hold with that part. I'm going to move on to some cleaning. I cleaned the outside of the machine a little bit. need to get inside. It's pretty nasty in here. That cooling fan is all caked up, and I believe the one on top of the motor is probably even worse. So now's the time to do it. And I probably need to hose down the inside of the machine too before we put in new coolant. I kind of wish I would have pressure washed it before I moved it into the shop, but it's too late now. Anyway, I won't bore you with that. I'll bring you back when we have something to report. I started cleaning, and things have escalated quickly. Looks like a CNC bomb went off in here. I pulled off all the way covers. Obviously, it hasn't been cleaned in a very, very long time, and now is the time to do it. I know if I don't do it now, it'll probably never get done. So, yeah, we'll get the shop back in here, suck up all the chips, make sure none of the lubrication lines are broken or anything like that. This is normal. I mean, you got to do this once in a while. We used to do it once every year on production machines. Over the Christmas shutdown, we'd tear them down like this and scrub them from top to bottom. They'd be clean for about 3 days. We've reached a familiar waypoint in the story arc of the used machine. This is the part where I wish, for once in my life, I hadn't bought the absolute cheapest and most clapped out machine known to man. What do you want first? The good or the bad? Let's do the good. I think mechanically the machine is pretty sound. These guides look nice and shiny. I don't feel any gouges. Same thing with the ball screws. Also, I think these are roller guides instead of ball linear guides, so they're a little more stout, which is nice. But you can see under the covers, this machine is pretty spindly. There's only 4 trucks for the table, and it has a pretty decent amount of overhang. This is not a big, stout roughing machine, that's for sure. But overall, I'm pretty happy with what I see. I don't think there's any major, expensive repairs needed to the mechanical part of the machine. And fortunately, the problems that we do have are pretty minor. This button is broken. A couple of buttons on the silicone keypad are also broken or missing. This indicator light is broken. There's supposed to be a pressure gauge here on the regulator. That's broken. And then this Waylube tank swings out, but the cap is missing. So I don't know if we're going to be able to find one of those. I might have to make one. This cover on the back, for some reason, there's a broken off bolt. Not sure if I'm going to fix that, but it is an issue. Inside the control cabinet, I noticed there's a broken locking tab on one of those RJ45 connectors back there. So we're going to have to replace these shielded Cat 5 cables. After spending a coon's age cleaning these fans, I decided just to go ahead and replace them. The blades are all rusty. The insulation on the wires is all melted. The bearings I think are okay, but this one, the sticker's been peeled off and it's been open. So they're not that expensive. We'll just go ahead and throw in some new ones. The only real problem is the way covers. And I anticipated that. They look rough on the outside and they're not any better on the inside. So there's supposed to be a rubber wiper seal all the way along each one of these joints. The rubber's gone. Luckily, this style you can just pry up this flange, stick in a new piece of rubber, and then smash it back down. Most of these rubber bumpers are also broken. So I'm going to have to spend some time getting these cleaned up and kind of evaluate what we need and how we're going to fix them. Well, fixing way covers isn't really difficult, but it's very time consuming. I scraped an entire box of metal chips out of the inside of those way covers, and every one of those chips is like a little razor blade. That's why it looks like I got in a fight with a bobcat. I did find some vestigial remains of the original wipers, or maybe the replacement wipers, I don't know, but that's what they're supposed to look like. So at least we can identify them. I pressure washed everything. That helped a lot, but these way covers are in really sad shape. They're pretty rusty, and where they're not rusty, they're really badly pitted. This machine must have sat for a long time and got pretty rusty. There's only so much we're going to be able to do about that. I'm going to probably run these through the blast cabinet, knock off the heavy rust, and then we'll try to sand them, see what we can do, but they're never going to be perfect. We've got to just accept that. A lot of the plastic parts are worn out, broken, or missing. These rubber bumpers are in pretty sad shape. I don't know if we can get that stuff, or if we're going to have to try and make it. You see they've got these little plastic bumpers here. They stick through a slot, and these ones are completely mangled. That one's missing, mangled, 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 missing, mangled. So we got to do something about that. A lot of them are dented and bent. I had to bend some of them to get them apart because there were so many chips between them. I couldn't actually get them to telescope all the way out. Like that roller hasn't been rolling for a very long time. Yeah, I think we can save them. Looks like about half of the way wiper casings are going to have to be replaced. They've worn so far that they've gone through this little lip that actually holds the seal in place. So you see part of that one's actually missing. It's paper thin on this end. That's the cover at the rear, and then all of the covers on the X-axis are going to have to be replaced. Luckily, it's not too bad. These are just spot welded on, so all I got to do is grind through the spot welds and peel off the old casings, and then we'll have to spot weld on new ones. That looks good. That does not look good. That's better. Much better. Okay, I ran into problem number 248 on the way covers. I ordered 5 meters of new casings and 10 meters of new seals. That's it right there. And what I got does not match the dimensions I was given. I'm not having much luck with the voice on the phone, so the company I bought them from is only about an hour and a half away. It's kind of early. I'm going to hit the road and drive up there. We're going to see if we can get it sorted out. If we don't have luck there, we're going to be in Rockford, Illinois. That's like the North American epicenter of way cover building and rebuilding. There's about half a dozen companies that do it, so I think we'll be able to find what we need. I feel like there's got to be a backstory to that road name. We're here, and I think we got what we needed. The only catch is it was a lot more expensive. There's $1,000 sitting right there. Hope it works. Kind of hard to get any work done when it's this gorgeous outside. Just don't drop the camera. Got a feeling we wouldn't get it back. There are 19 individual way covers. Each one's been stripped, scraped, washed, sandblasted, straightened, and sanded. It's taken about 40 hours to get to this point. And they're not perfect. You know, they're never going to be like brand new, but they're going to be a heck of a lot better than they were. The only one I'm a little bit worried about is this big one at the back. There's some pretty deep gouges here that I couldn't really get out. But the guy at the way cover place where I bought the seals, he said, you know, don't worry too much about that. He said as long as they're not so thin that they want an oil can, they usually work just fine. So we'll go with what he said. I mean, he would know. They work on these things all day, every day. Like it's like dead. Yeah. But I mean, mechanically, was it in pretty good shape? Like the tool change arm? Okay. But the servos and drives and stuff are still there? Yeah, I mean, it hasn't really rained, so shouldn't have hurt it too bad. Okay, hey, thanks for calling me back. I'll be in touch. Yep, bye. Well, that's interesting. Is that a combine? No, tractor. They are farming up a storm out there. I think all the parts are here, and we're ready to start putting this machine back together. But there's been an unexpected development in the Hurco saga, which means we're going to have to cut things off here. We'll call it part 1, and we will continue this adventure in part 2. Thanks for watching. I really wanted to make a video about this sweet 2000 Toyota Tacoma. It had a brake problem. It turned out to be a leaking brake line, but I couldn't fix it. There's the brake line. That guy right there goes into this leveling valve or proportional valve or whatever it is. Unfortunately, there's a much bigger problem. That's what's left of the frame rail on the driver's side. I don't know if you'll be able to see this, but it's actually broken. I mean, completely broken in half. I really think the trailer hitch is the only thing holding the back end of this truck together. The cross member above the spare tire is completely rotted out. It's actually pretty much broken on this side. This brace here for the rear spring hanger, it's completely gone. Someone has already patched the frame rail on the passenger side. Done a pretty good job of it. I mean, it doesn't look bad at all. Unfortunately, now it's all rotted out and broken on the inside. That is probably a death sentence for this truck, which is too bad because the body really is in good shape. It's four-wheel drive, it's got a locking differential. It's just a cool truck. I love these late 90s, early 2000s Tacomas and 4Runners. I'd love to have one, but unfortunately they all look about like that. Normally I'm up for any kind of sketchy repair, but I draw the line at welding up frames. I know everybody in the comments always tells me about how easy it is. My standard response stands. Go ahead and send me your contact information. I've got a lot of work to send you.